class which can be used in your programs. Next class is random class. You Math.random to obtain a random double value between 0.0 and 1.0. A more useful random number generator is provided in the java.util.random class. These are the different sort of methods which are residing into that particular class. Random, it constructs a random objects with the current time as its need. Then random within the bracket seed long constructs a random objects with a specified seed. Then next integer int, it will return a random integer value. Next int int returns a random int value between 0 and n. It is exclusive as well. Next long, it will return a random long value. Next double, it will be returning a random double value between 0.0 and 1.0. Next is similarly next float, which returns a random float value between 0.0f and 1.0f. Next boolean, it returns a random boolean value. Boolean values are always given in true or false. So this is the random class and the different methods of that random class. Let's discuss the functions which are given in the date class as well. Date, it will construct a date object for the current time. It will display the current time and date as well. Next method is date elapsed time long. It will construct a date object for a given time in milliseconds elapsed since January 1, 1970. This is this already specified time into those methods. So always it will pick the time from those dates only. toString, next method is toStrings, returns a string representing the date and time. The next method is getTime. It will return the number of milliseconds since January 1, 1970. Next method is setTime. It will set a new elapsed time in the object. So these are the date class methods. Next were the random class methods. We have a number of classes which can be used to display the graphical user interface components. We have applet class, AWT, that is abstract windowing toolkit as well. Whenever you develop program to create graphical user interfaces, you will use Java classes such as JFrame, JButton, JRadioButton, JComboBox and JList to create frames, buttons, radio buttons, combo boxes, lists and so on. Here is an example that creates two windows using the JFrame class. All these classes which I have told you, JFrame, JButton, JRadioButton, they come under the main class which is JFrame class. Next is static variables, constants and methods. The static variables are shared by all the instances of the class. Static methods are not tied to a specific objects. Static constants are final variables shared by all the instances of the class. You must have noticed the static keyword in the public static void main as well. The static variables are shared by all the instances of the class because they don't need to use the objects of that particular class. The static methods are not tied to a specific object because they can be called without creating object of a class. For an example, the public static void main, which is the main method, it can be called without creating object of a class because it contains the static keyword into that particular line. Static constants are final variables. The final variables are the one whose value cannot be changed at the runtime once declared. They are shared by all the instances of the class. The next is visibility modifiers and accessors, mutator methods. And as I had told you about three of the SS specifiers in the beginning of the lecture. By default, the class, variable or methods can be of type public, private or protected. The public, if you are writing the public keyword in front of a class, it means it can be accessed by any class in the same package. The class, data or method is visible to any class in any package. if you are attaching the keyword public in front of a class or in front of a variable or in front of a method, that class, data or method will be visible to any class in one package. But next is private modifier. The data or methods can be accessed only by the declaring class. If you are writing the private keyword in front of a class or a variable or a method, that means you are restricting the access to that class, restricting the class access of the methods and the variables and the class to that particular class only. The get and set methods are used to read and modify the private properties. The third modifier, which is not discussed in this PPT, is protected modifier. It is also an access specifier, and it is always used in the case of inheritance. If you are declaring a class protected or the variables or the methods of a class protected, that means that class and the variables of that class, methods of that class will be visible into the inherited class. So, these are the visibility modifiers. It is an example of the different sort of modifiers which can be used in writing a classes. The private modifier restricts access to within a class, the default modifier restricts access to within the package, and the public modifier enables unrestricted access. So, if you want to limit the access to your class, you may use the private modifier in front of your class, but if you want to restrict the access to your class within a package, if you want that your class should not be accessed outside the package, you may use the default modifier. And if you want to make your class visible to each and everybody, you can use the public modifier. Next is garbage collecting refinements. We have generational collectors. These are the techniques of the garbage collection. You may divide the block into generations according to the age, then garbage collect in your younger generations more often using previous methods. Next is incremental collectors. They collect the garbage a little at a time, then avoid the uneven performance like mark and sweep and copying collectors. We have three major approaches to the garbage collection by which we can achieve the garbage collection. First is mark and sweep, second is copying, and the third is reference counting. Let us discuss the first one, which is mark and sweep. It uses current heap links in a two-stage process. Mark, it will find the live heap links and mark all the heap logs pointed by them. Then by using sweep, it makes a pass over the heap and return unmarked block to the free pool. Both kinds of inclusion errors are tolerated. Blocks are not moved, so the fragmentation may remain. This is the way how the mark and sweep is done. The live heap links are marked in the red. The sweep will return the unmarked block to the free pool. Next technique is reference counting. Each block has a counter of heap links to it. It is incremented when a heap link is copied, decremented when a heap link is discarded. When counter goes to 0, block is garbage and it can be freed. So, the reference counting basically uses a counter, and whenever the value of the counter becomes 0, that means the block is garbage and it can be freed and the memory can be used by some other object. It does not use current heap links, which was used in the mark and sweep method. And the third method is copying collection. It divides memory in half and uses only one half at a time. When one half becomes full, find live heap links and copy live blocks to the other half. Fragmentation is eliminated. In both earlier techniques, the fragmentation may remain. Fragmentation means parts of your memory will be scattered here and there, and between those parts you may have free memory. Fragmentation is eliminated in copying and collection. It will be moving blocks. It cannot tolerate inclusion errors. Why? Because that use variable will be mistaken as a link and hence modified. So, this is the way how copying collection will look like. Cannot tolerate used inclusion errors. In reference counting, we had two problems. Cycles of the garbage and overhead of updating reference counters is high. We must be having a number of cycles of the garbage, and after that the second problem is the reference counters. We will have to update the reference counter again and again. One advantage of this method is more uniform, that is cost is incremental, no big pause while collecting the garbage. There are number of languages that offer garbage collection these days. For example, these are Java, ADA. In C and C++, it is difficult to achieve garbage collection because not possible even for C and C++. There are libraries that replace the usual malloc free with a garbage collecting manager. So, the summary of the lecture is a class consists of a collection of fields or variables, very much like the named fields of a construct. A class describes objects and operations defined on those objects. Classes are arranged always in a hierarchy. Java is a case sensitive language. So, whenever you are writing a class with small letters and a class with capital letters, JVM will consider them different classes, two different classes, because Java is a case sensitive language. Otherwise, you may have an error like no class definition found as well. Underscores are not used in the name. Underscore, and you must avoid all the special characters whenever you are naming your class. One more thing, that your class name should be similar as your file name. After writing a class, when you are saving your file, you must keep in mind that your file name should be same as your class name. The classes, objects and methods are the basic components which are used in Java programming. The Java programming is based on these three components only. Java uses dynamic memory deallocation by using garbage collector. It will be deallocating the memory automatically whenever an object is not used for a long time. The memory management is an important hidden player in language systems because performance and reliability are critical. Different techniques are difficult to compare since every run of every program makes different memory demands. Still an active area, the garbage collection and memory management, it is still an active area of language system research and experimentation, because different languages are making research and experiments in order to achieve much more good methods of collecting the memory of dynamic memory allocation. That's all for today. Thank you.